All right. Starting with this one, a truck has an initial speed of 20 meters per second and decelerates at 4 meters per second. So we know that's v0, we know that's acceleration, and we know that's our vf. So we have vf squared equals v0 squared plus 2as. Solving for s, we get vf squared, which is 0 minus v0 squared, divided by 2a. And remember, our a is decelerate, so our a is negative. So plugging that in, we're going to get c. Number 2, a projectile is fired at an angle above the horizontal. Okay. Air resistance is negligible. The path of the projectile is shown. So first, step 1, when looking at a graph, this is your vertical displacement, this is your horizontal displacement, which gives the magnitude of horizontal component and magnitude of the vertical component between O and P. So we're only looking right there. This is a nice smooth parabola. So with it being parabolic, then we know that the horizontal component has to be constant, and the magnitude of the vertical component of velocity is speeding up because acceleration is acting in the same direction as your velocity. So that's A. Let's see. Number 3, a runner starts from rest and accelerates at a constant rate throughout the race, which graph shows a variation of speed, distance traveled. So rule number 1, let's look at our axes, velocity versus displacement. Speed with the distance traveled. Some of you may have been tempted to put this because it says constant rate throughout the race without looking at your axes. But what's happening is we're starting out with a high speed and then leveling off. This graph says we're starting out with a low speed and then speeding up. And then this one says we're the same. So if you've ever had the unfortunate experience of running, you know you're starting out fast and then going slower as your displacement continues to move. So A, 2 blocks rest on a frictionless surface. That's important. A horizontal force is now applied to the large block, so that moves together at the same speed. So because the force is acting to the right, friction opposes motion. We already know that the force of friction in the y is gonna be to the left. So that eliminates B and C. And then X, inertia, is gonna keep this box X right where it is. So as block Y moves to the right, block X is going to apparently move to the left, which means the force of friction on X is going to be to the right. A. What's next? Choose photo. Yes, that looks great. Spring is used to launch an object along a horizontal frictionless surface. When the spring is compressed through a distance x and released, the object leaves the spring at speed v, which is the distance the spring must be compressed to leave at half of v. Well, we already know that the spring, an ideal Hookean spring, will follow Hooke's law, negative kx. And what this really tells me is force is proportional to displacement. If force is proportional to displacement, then acceleration must be proportional to displacement because mass is going to stay the same. So as we're accelerating, if we only need to go half the speed, then we only need to accelerate for half the time. X over 2. Number 6, I'm going to put a star next to number 6. We're going to have to talk about this one in class. projectile is filed at an angle of the horizontal, which gives the magnitude of the horizontal component and magnitude of the vertical component of the velocity of projectile between O and P. So just that point right there. Very similar to the question we did last time, but with a twist. This time it is not parabolic motion. Not only that, but we're looking at our vertical displacement plus horizontal displacement, or versus horizontal displacement. So as our horizontal displacement continues on, our vertical displacement rapidly appears to drop off there. So we know that there must be something slowing down that horizontal displacement. And then we know that our vertical component is going to be speeding up right there. It's going to be getting faster and faster. So that leaves us with A. Bye, have a good day. Bye. Have a good day. Three forces act on a point. In which diagram is the point in equilibrium? So what we're looking to do is get all of our forces to cancel out. So that's the point that they're acting on. So this F2 component has to match up with our F1 component. But we can tell right away that our vertical components don't match up, and all three answer choices have nothing but a horizontal component. So our vertical components, that's our big clue, our vertical components need to cancel out right away, right? So the only ones that appear to cancel out right away are B and C. Now let's look at our horizontal displacement, or excuse me, horizontal component, which is that and that. Those two added together have to be canceled out in the opposite direction. So you're adding this and this. And down here you're adding that basically twice because those two are essentially going in the same spot along the x-axis. So we'd be looking at twice that to the left, which is only going to get you about there. D is not long enough. We already canceled out D. What am I talking about? F2 goes this far, and then F1 goes that far, so we're expecting to have an F3 really long. So our answer is B, because our horizontal component for each of these forces added up, and then anti-parallel, F3. That does it for the multiple choice. I'll make another video for the free response.